We know how to divide two numbers, right? For instance, 5 by 4. 5 can be divided by 4 using the standard division format as shown, which we already know. We know how to verify this division as well. We should get the dividend by multiplying the divisor with the quotient and adding the remainder. In general, the division of A by B can be verified by checking if A is equal to B into Q plus R, where A is the dividend, B is the divisor, Q is the quotient and R is the remainder. But note that this remainder R should be less than the divisor B. This equation is called Euclids Divisionlemma. The Euclids lemma states that for given positive integers A and B, there exist unique integers Q and R satisfying equation A equal to B, Q plus R, where R is greater than or equal to 0 and less than the divisor B. Euclid's division lemma helps us to find HCF of the given numbers. This technique of finding HCF of two numbers using Euclid's division lemma is called Euclid's division algorithm. Let us see this by considering an example. Find the HCF of 100 and 86. To find the HCF of the given numbers, divide the greater number of the two by the smaller number as shown. In this case, 100 is the dividend and 86 is the divisor. Apply the division lemma. We get the equation 100 is equal to 86 times 1 plus 14 as shown. Now take 86 as our new dividend and 14 as the divisor. On division, we get the remainder 2. Using the division lemma, we can write 86 is equal to 14 into 6 plus 2. Now with 2 as the new divisor, 14 as the new dividend, the remainder is 0. So 2 is the HCF of 100 and 86. So what could be the logic behind this? How is this working? It is because the HCF of 100 and 86 is equal to HCF of 86 and 14. And again, HCF of 86 and 14 is equal to HCF of 14 and 2, which is 2. And so, HCF of 100 and 86 is 2. In general, we can say that if A is equal to BQ plus R, then HCF of A and B is equal to HCF of B and R. Let us now discuss the general procedure to find HCF of any positive integers, say A and B, where A is greater than B. Using Euclid's division lemma, we can write A is equal to BQ plus R, where R is greater than or equal to 0 and less than B. If the value of R is 0, then B is the HCF of A and B. If the value of R is non-zero, apply the division lemma to B and R. Continue the process till the remainder is 0. The divisor where the remainder is 0 will be the HCF. The process is shown here as a simple flowchart for you to remember easily. Step 1. Consider two positive integers and apply the division lemma. Step 2. Check if R is 0. If yes, B is HCF of A and B. If no, replace the value of A with B and the value of B with R. Then repeat the whole process until we reach this step where R is 0. The divisor at this step will be the HCF. Let's quickly recap what we have learnt in this session. We have recalled Euclid's division lemma and we learned the process of finding the HCF of two positive integers using Euclid's division algorithm. That's all for now. I'll see you in the next session. Till then, keep learning.